Okay, so let's talk about 811. How can I build this? We're going to be talking about polygons, meaning we're going to be starting talking about shapes that have five or more sides, like pentagons, hexagons, and so forth. So in the previous chapter, you studied triangles and quadrilaterals. In chapter 8, you'll broaden your focus to include all polygons, and we'll study what triangles can tell us about shapes with five, eight, or even 100 sides. So this is still going to be triangle heavy. We're still going to use triangles as the foundation for these shapes. But by the end of this lesson, you should be able to do the following. You can use the number of sides of a regular polygon to find the measure of the central angle and what type of triangle is needed to form a regular polygon. Um, so regular means the following. All sides congruent and all interior angles congruent. So here's like a very classic example. Okay, I didn't draw it perfectly. How many sides does this have?
Six.
And what do we call that? Hence five. Hexagon. So it so happens that all these sides are all the same. All the sides are all the same. And all the interior angles are all the same.
Definition of hexagon.
Regular, regular. Hey, girls, please. Thank you. So a regular hexagon, sorry. Thank you for clarifying, Connor. So yeah, regular means all the sides are the same, all the interior angles are the same. So we're going to work through this today, and we're going to do a little activity. So let's read the activity here. Inez loves pinwheels. One day in class, she noticed that she put three congruent triangles together so that one set of corresponding angles are adjacent. She could find a shape that looks like a pinwheel. Okay. Can you determine any of the angles of her triangles? Explain how you found your answer. Um, okay. And the overall shape of his pinwheel shown at the right. How many sides does it have? Wasn't a name for this shape. So what I like you guys to do, you guys have this sheet here, is I like you guys to actually we'll cut this out in a moment. We'll do the cutting in not yet. Let's just take a look at this diagram here. So if you think about it, you determine any of the angles in a triangle. Okay, there we go. Okay, so first of all, these are congruent triangles, right? Let's back up here a little bit. Okay, it says congruent. Yeah, it says congruent. And actually, you'll have that in front of you as well because you're gonna be cutting out these triangles. Um, Let me zoom in because it's kind of hard to see. Okay, so if I focus on this pinwheel here, how many degrees is that? And how many angles am I looking at?
Three.
Three. So if I do 360 degrees divided by 3, you should get 120 degrees. Good. 120 degrees. Okay. Okay, girls. Thanks. All right. Now, overall, the outline of her pinwheel shown at the right. How many sides does it have? So if we kind of count 1, 2, 3, 4, 5, 6. Yeah. So this is a hexagon. There's six sides, but it's kind of a fun hexagon, right? Um,
Is that the title of the shape is fun hexagon?
Fun hexagon? No, just call it hexagon. It's fine.
Size of
No, this is not regular.
wait, then what? Oh, on the markings just to show the side?
Correct.
Oh,
Right.
no.
Oh, yes, that's correct. The markers are just show the sides. You're right. Maybe that was confusing. Yeah. No, maybe I'll do this then. 1, 2, 3, 4, 5, 6. There we go. That's much better. So it's not regular. In fact, actually, we call this a concave.
Convex.
Correct. We're going to be focused on convex in this unit, but this is concave because what happens if I were to pick two dots inside the diagram and drew a line connecting those two dots, does that segment stay fully inside the diagram?
No.
No. That's what makes it concave. We're not going to be working on concave in this unit. Convex is going to be our main focus. Ollie, go ahead. Yeah. Yeah, that works too. Yep. All right. So now let's move on to part C. So Nez's shape is an example of polygon because it's closed two-dimensional figure made of non-intersecting straight line segments connected end to end. As you study polygons in this course, it's useful to use the names on the following page. We'll do it right now because identify how many sides a particular polygon has. Some of these words may be familiar with, others may be new. So here it is. So let's turn the page, guys. So we know the first two for sure, right? We spent a lot of time on the first two. Quadrilateral. Just talking about pentagon and hexagons. Pentagon, hopefully if you know your U.S. politics or government really well, there's a Department of Defense building that's shaped like a pentagon.
There.
Called the Pentagon, right, for a reason.
I have a photo of it.
Pentagon is kind of a rare one, so we don't really deal with that. For those who like watching MMA or UFC, the octagon is like it's a ring with 8 sides. It's very bloody and gruesome. Nonagon, non means 9. Since we're talking about Olympics, but this is for Summer Olympics, you have the decathlon or decathletes. They run 10 events, right? So
Wow.
decade means 10 or decades. Decathlon? No, 10 events.
It's like one race and
Well, no, it's a lot of different things. Things like high jump, long jump. It's like track and field stuff.
Does it, in that case, you do have anything to do with the node?
12 faces. Once you get past 10, if you just have like, let's say you got like 25 sides, just call it 25 gone. Or dumb joke, you have 67 shape sides, 67 gone. Okay, 6, 7, yeah. Okay, let's keep going. Oh, my Milky Talks says all the time. Yeah. Just ends and number of sides. So it's just a general way of saying it, that's all. So that's it. Okay. So now, and Kira, please don't cut your hair. Okay. All right. All right. So let's look at A2. So now we're going to start doing this activity, right? So cool. So Inez is very excited. She wants to know if you can build a pinwheel using any angle of her triangle. So now the resource page is actually the orange sheet in front of you. So the resource page is the orange sheet. You guys already have that.
Are we cutting them out?
Yeah, exactly. So you and your team. So we'll do this in pairs, but just have one group of 3 because Maggie's taking a test. Then work with your team to build pinwheels and polygons by placing different corresponding angles together at the center. You'll need to use the triangles from all 4. That's just you and another person to build one shape. Be ready to share results with the class. So what I'm going to have you guys do is go ahead and do the cutting.
Should only 2 of us put it out stable.
Sure. It's up to you guys.
Alright.
But what you want to do is focus on only focus on the top one right now, not the bottom. The bottom will be the liquid. Oh, you got the bottom. We're gonna use that later. That's fine. But for now, you just focus on the top one. And what you want to do is organize in such a way where you get all these different shapes.
Really fun.
Oh. Okay. You soccer went in the rain.
Wait, we cut all the individual ones?
Yeah, just for A2. Yeah, cut out all the individual ones, right? So I'm actually gonna do it too with you guys.
She told me. That's so mean. I was burning the other day. You should have.
Should we cut out?
Yeah, so.
It's seriously, it's
Wait,
Abington,
oh my.
like a lot, like Fieldsworth, we did like there and back 3 times. With a stick and a ball you took available time, and then we had to do that 4 times.
We said he's not like been
Like
like
full
sprint.
field.
Yeah, well, we're gonna do something
You have to do it under a certain amount of time.
He's out too.
Like, you have to do it under 60 seconds, and it was like full field length, 3 times there and back, under 60 seconds.
Wait, how, like, Gator Nation field?
Like,
Or they just like, like.
no, like, but no, no, no. No. It was like,
I don't know, it's kind of.
it was, but not most people didn't make it.
My mom was like. Guys, I like, I like, I never ran some like in club soccer. What I remember, one time, she like, we had like a bracelet. Like maybe like a month.
Yeah.
And we were like, people were not, people were crying. Running up and I had like, dropped how much my life, like, it was so much fun. Now, so bad. I was like, no, my team was like fine. We only like back up. It's like literally like a cricket function. Have you seen like I remember one practice like have you ever been to Murrayfield? Yeah, huge field. Our warm up. Oh yes, our warm up was 16 miles across. Then we had to like yeah, across the whole fucking field. I was really excited. Anyways, and then we do this. Did you ever do 5 minutes? For soccer, I don't know, maybe this happened, but it would be like 5, 10, 15, or 20 minutes. And you'd like be like a run. I was like wondering if you'd be like a run, if you like you'd say half of the time. And you would have to like either sprint, they'd make you sprint and go down, and then if they give you like and then you can jog, but if you like put it and then you go down. So it's so fucking long.
No, I hate running. I have trauma because it's volleyball. It's terrible. Like, the volleyball shot, I it's way too hard for what we actually do at volleyball. I have.
Yeah.
I will.
Yeah,
not,
good.
like,
You guys, once you have these 6 triangles cut out, what I want you guys to do is start rearranging these so that like, so you create pinwheels, right?
So bad.
Correct. So we already know if you put angle ones, all the angle ones together, you have 3 of them. And 3 angles. Alright, alright.
Put out some triangles in here.
Yes, correct.
See, I don't know where my knife went. Are we eating these?
Okay, so yeah, you guys have that, which is good. So angle 1 is 120 each.
Mr. B, I literally lost my.
So what we're noticing is that we have 100, yeah, what we're noticing is that we have, 3 triangles that form a circle.
Mystery, can I have another paper? Cause I lost one of my.
Oh yeah, so some orange ones right in front of the theater room display. So what we're doing here, according to the notes.
Oh wait,
I
I
not
not
hurt.
like it hurts like it's tight and sitting down on it, but like these ones are really hurt. But anyways, my surgery's in a week, so this is my last week like being open. So like I'm like walk or like literally maybe like 2 months.
But that at least it's the
No, but so like even when I go to Mexico, like all my stuff, like I still have to wear my.
When are you going? Mexico? Right?
Yeah. I just want to my room is going Sally swam so much.
But I feel like it's better to have it all the time. And then you don't have crushes in the summer. You can alter crushes. Yeah. This is now, this is the best time.
Oh my gosh, it's like, they'll probably be on the medicine you use for it.
Yeah.
I think I mean, if it's a novel.
Yeah, I know.
Well, I do, because I would need to do check.
How do you just
Yeah,
I don't want
that's what they said. They were like.
Guys, here's what I want you guys to try to make. I'll give you guys some guidance. It looks like you guys need a little guidance here. All right. All right. So what you may want to do, okay, guys, quiet, please. Thank you. So if you look at yeah, sure, go ahead. So this is like 1, 1, 1. And I think angle 2 is the second biggest angle. So I think angle 2 is like here. Angle 2 is like right here. And angle 2 is like right here. Okay, what if you guys tried doing this? Take this triangle out. So you have something kind of like that.
I didn't do it.
And then take 3 of the triangles. So take 2 triangles that are joined at angle 1 and take 3 triangles and use angle 2 and see what you create that way.
Is it okay if we turn it over to the white side of the paper to do this?
Sure.
And then I.
So if you think about it, okay. So if you think about it, angle 1 was 120 degrees, right? Because we had 3 of the triangles form a full circle, right? We had 3 of the triangles form a full circle. So it kind of looked like this, right? Yeah, it kind of looked like that in a way. So, but can you guys create something like this here? If you create that, you have another full circle, right? If you have another full circle, angle 1's 120 each. What would angle 2 be? Okay, so what is that? Hold on, guys. Okay, girls, you gotta stop talking. Seriously, if you can leave this class if you want, but this whole time you've been talking nonstop, all right? And that's so disrespectful. Are we clear?
Yeah.
Thank you, because I'm trying to teach. All right. Now, Kira, you're gonna help me out here. Okay, so angle, right? Okay, now we're cool. All right. So we had angle 1, right?
How did you connect angle 1 with angle 1?
So what we did is I took 3 triangles with angle 1. Let me try drawing it. Hold on. We'll just look at this one here, right? Okay, so we had 3 triangles with angle 1, right? And if we go around once, so that's 360 degrees. So what was the measure of each of angle 1?
120.
120, good. Now let's take one of those triangles out. We're just experiments, all we're doing. We're just kind of playing around with this. If I take this triangle out and try replacing that with 3 triangles, both angle 2. Good. How do you get that, Peter?
Well, because if 120, it makes 360.
Right.
It'd be 240 minus 360 and then divide that by 3.
Yeah, so what happens, I could rearrange in such a way where these are all angle 2s, right? So I have angle 1, angle 1, angle 2, angle 2, angle 2. That still adds to the 360. So 1 plus 1, I know it sounds weird, right? 1 plus 1 plus 2 plus 2 plus 2 equals 360, but I'm referring to as angles, right? So that's the possibility. I have 5 angles adding up to 360. We already know angle 1's 120 each. What's angle 2 going to each be to make this work? Do you see why it's 40, 40, 40? Why is it 40, 40, 40? Well, these were 120 each, right? And the whole thing has to be 360. So what do these 3 angles just have to add up to? 120. And what's 120 divided by 4? Sorry, divide by 3. 40. Good. So that's what we're doing. We're just trying to just play around with this a little bit, trying to see different shapes we can make. But maybe let's just move on to 8-3. I think that's probably a good thing to do right now. So let's just move on to 8-3. So next up. Okay, will all triangles build a pinwheel or a polygon? The answer is yes, they will. So that's what we're going to try to do. So how many triangles does it take to build the pinwheel? Oh, good. Sure, yeah, no problem, yeah. Okay, so the next thing we're going to do, grade 3, I'd like you to cut out each of these triangles. So you have 4 triangles here. And we have another 4 here with D, E, F, right? And what we're going to do, yeah, if you've never done so, cut the remaining triangles, work together to determine which congruent triangles can build a pinwheel or polygon. And when corresponding angles are placed together at the center, when they're placed together at the center, okay. For each successful pinwheel, answer the questions below. How many triangles did it take to build a pinwheel? Calculate the measure of a central angle of the pinwheel. Remember, the central angle is an angle of a triangle with the vertex at the center of the pinwheel. Is the shape familiar? Does it have a name? If so, what would you call it? So let's go through that right now, all right? And I'll come around and help you guys out. So, all right.
The polygon have more or less than 4 centimeters. I mean, I know it's have more, but can it have less than 4 centimeters?
Well, it'll be triangle.
More.
Can a triangle be a
Yeah, it is polygon. Yeah, it is. Yeah.
We already have our whole groups cut out.
I did it also to you guys.
Oh, okay.
Okay, so let's rearrange the ones with A, B, D, D, F.
We took it out this week. So.
Yeah, that's all I hope so.
Oh, no. It's not after the production. Guys, go to this. Go to the middle of the inside.
Done by what?
First on the box wall.
Oh, yeah.
Friday? Yeah. Wait, let's see here. Yeah.
At Secret?
Yeah.
Varsity boys?
Yes.
Oh.
Okay. I get to walk out. It says they're saying it.
Oh my god.
Yeah.
Wait, what is it?
Yeah, so, yeah. Stop in. I'm gonna trade for that.
I kind of don't want to. You know, like, yeah.
No, strip, I didn't know.
That's so crazy. Your ACL, like, it looks fine. Right?
I would not know if I know.
Yeah, I wouldn't even know if like those. You look like she's gonna surgery. Yeah. No. Oh. Carrier. So bad. It doesn't hurt. It hurts like it. I compare it to the pain like you cry. Yeah. I'd compare the pain like a sprain. Let's go like abusing the internet. They kept like doing stuff like me. Yeah.
Okay, I connected that.
Okay, so let's take a look at what Reagan's got. All right, so you got E 4 times and B 4 times. Okay. That's fine. We're experimenting. That's all we're doing. All right, so you count it. Number of sides. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. I lost track already. 1, 2, 6, 7, 8. So it seems that B is probably 60.
But that's I was like my last days. Because why didn't they?
Yeah.
Find like angles, like there's a different amount that's needed to build the.
Right, correct. So here's so here's what guys, here's what we're doing. Every single time we're building this, right? We want to build it so that the angles all up to 360, right? All the angles in the middle out to 360. That's kind of the key idea here. Right. So like for example, so every central angle, or sorry, every angle. Okay, guys, quiet, please. Every angle we use must be a factor of 360 degrees. That's kind of the key takeaway here. I know it's kind of hard to see that. Actually, I think it'd be easier if I gave you guys more of some of these triangles. Like for example, Reagan had a good one where she had E 4 times, and I think B 4 times. I think angle B was like 60 degrees, if I'm not mistaken.
Yeah.
Angle B, I think it was 60 degrees.
Yeah.
And I think angle E was 30 degrees.
Oh, I think
B would be.
B is like 40 and C is 30 or something like that. I don't know.
Let me double check.
Wait, yeah,
Because aren't all these supposed to be right?
16 option.
So if you guys take it's kind of hard to show it. If you guys take 3 of the triangles that have DEF on it and join 3 of them where angle E's are all meeting at the middle, you can see that looks like 1/4. Like if you have something like this here.
You want me to hold it up?
Sure, if you don't mind doing that. Okay, I didn't draw it that well. Okay, if you do that, what Reagan's holding up right now, what do all 3 of these, if you think about it, how many of these would I need to make a full circle? More than 10.
Wait,
20.
12. You need 12. You need 12. So right now, you need 12 of these, right? 12 of these would form a circle. Okay, so 12 of these form a circle. So what's going to happen is that we know the angle E is going to have to be 30 degrees. But see, if it was like a weird number like 32, for example, there's no way I could add a bunch of 32-degree angles to get up to 360, right? I get pretty close, but not exactly. 40 I could. If I take a bunch of triangles at 40 degrees, I could do a bunch of those, and that would add up to 360. So it says here, whereas a triangle with angle 32, 40, 108, will this triangle be able to form a pinwheel? It would for the 40 degrees. 100% you could do that. No, we have to use one of those at a time. Right. That's what I was trying to say. So the bottom line is this, that we need every angle we use must be a factor of 360. So you have to make sure 360 can be divided by it.
Are you laughing?
Sure, that's fine. Yeah.
Wait, so it's not a different.
No, it can't be 32 or 108. Well, 40, right? Because if you think about it, if you do 49 times, 40 times 9. Correct. Right. So yeah, let's just jump to. So let's look at A4. So she wants to create a pinwheel with equilateral triangles. Now, if you have an equilateral triangle, what's the measure of each angle? 60, right? So how many equilateral triangles will she need to make a pinwheel? More than 3. She needs 6.
Oh.
Right? Because and actually what you wind up creating is a hexagon. So let me show you this here. Yeah, sure. So if you think about it, if I put 6 triangles like this, I think this is much easier to see than all the other stuff I've been working on. Right, because you go around 360 degrees, right? And you split 6 ways. So this is what we call a convex polygon. And that's because it doesn't cave in, or any 2 points you draw within the polygon will stay fully inside the polygon. So a convex polygon is one where any segment connecting 2 points will stay inside the polygon. Or is the way of writing it, any segment connecting 2 points is fully inside the polygon. So that's what we call a convex polygon. Okay, so if we move on to some examples. So like, for example, these are not convex. We call these concave. Oh, wait, hold on. I'll go back. That's fine. Here we go.
Okay.
So, but the next page will make it more clear, right? So, yeah, non-convex is the same thing as concave. So, for example, if I draw these 2 dots, see, that's not fully inside, but can you make that happen for a convex? Not really, right? Like if I pick any 2 dots here, it's going to always stay inside the diagram. So think of concave as like caving in. Like there's a cavity, right? You see there's a bit of a cavity here or here or here. Like there's these little pockets, right? Or like that's totally caving in over here. But that won't happen for convex. Any 2 dots I draw inside will always stay fully inside. Okay, this will be pretty much the last thing we'll talk about, section problem 8.5, then we can be done for today. And the homework will be homework 13, which is in your packet, and I'll put it in the Schoology as well. Okay, when corresponding angles are placed together, why do some triangles form convex polygons while others do not? Consider this as the answer to the following questions. Carl wants to build a convex polygon using congruent triangles. He wants to select one of the triangles below to use. Which triangle will build a convex polygon if multiple congruent triangles are placed together so that they share a common vertex and do not overlap? So which triangles will build a convex polygon? Okay. So basically we want no overlap, right? And by the way, that's 40 degrees right here. 72, that's 108, that's 54, 54. 120s are all different. 60, 70, 38, that's 142. Is that right? 71, 71. And 20, that's 70, 70. No, 80, 80. Okay, let's look at the first one. Are any of those numbers, those angle measurements, that's what I meant to say, are any of those angle measurements a factor of 360, or can be 360 be divided by any of those angle measurements for triangle 1, and it comes out nice and clean? Like if I did 360 divided by 54 or 360 divided by 72, which one of those would come out clean? You use a calculator if you need to. It's totally fine. Yeah, 72 for sure. Yeah, because that's gonna be 5. So what that means, I'm gonna draw 5 more, just like that. We're all done?
Yeah, but I have like, 2 questions.
Can you wait a few minutes? Yeah. All right, I'll hold on to it for a while. Yeah. So if you think about what kind of shape am I making over here? Almost. Pentagon, good. Pentagon, right? That's a pentagon. Okay, what could I make for this one here?
Okay.
Well, not quite. It's still giving me a triangle, right? That's still a triangle. Because you do, what's 365 by 120? Is 3, right? So what we're doing is we're looking at central angles. Okay, take a look at the third triangle. How many of these would I need to connect to generate a convex polygon? Like just a full rotation. How many of these would I think I need? Why 18? Yep, 365 by 20, right.
18 gone?
18 gone. I don't know a special name for it. What about for triangle 4?
9.
Nonagon. Yeah, nonagon. You're doing 365 by 4.
Is a 9 gone?
You go 9 gon if you want. It's fine. Right. Yeah, so you can get that happening. 5, but it won't be convex though. Because not all the angles are the same. But yes. That could work. That would be a hexagon.
5, but it not be.
But it won't be convex, it'd be concave. Because you need to have all the base angles be the same. Because when you have a regular, correct, right. And that's what we're going to talk about on Thursday. And then lastly, 6, just it can't be anything. Yeah.
Not a factor.
Can't be anything there. So yeah, so that's what we get for 1, 2, 3, 4, 5, 6. So the homework, let's just talk about that real fast. It's gonna look like this here. A lot of it should be pretty straightforward. Like, hey, let's just find X, right? For all these triangles. 8-7's asking you to name these shapes. 8-8 is more just on angles. 8-9 saying the relationship, that should be pretty obvious. 8-10 is more on the same stuff we talked about. 8-11 is review of just triangles in general. 8-12 we already talked about. That was kind of on the test. And then 8-18 is right here. Yeah. So, and the answers show up. So anyhow, so we haven't really got too deep with this yet. It's more just like exploring the shapes. That's all we kind of just did today. And just talking about what a polygon is. So we're all set. So we got a few more minutes. You guys can just hang out and relax, and I can take care of Becca's questions. So yeah.